James Webb finds possible traces of life, just discovered on planet K2-18b, 124 light-years from Earth. Remember those childhood nights under the stars, eyes wide with wonder, whispering to the sky, "Is anyone out there?" That timeless question has echoed through generations, in myths, in movies, in science classes. And now, in 2025, the James Webb Space Telescope, JWST, might be bringing us the closest answer we've ever had. A small, dim red star in the constellation Leo, a planet called K2-18b, and a whisper from across 120 light-years that we might not be alone. The big discovery, a whiff of alien life? Using JWST's ultra-sensitive instruments, astronomers detected something extraordinary in the atmosphere of K2-18b, dimethyl sulfide DMS. Now, if you're wondering why that matters, here's the kicker. On Earth, DMS is only made by living things, specifically marine phytoplankton. In other words, life. Alongside DMS, scientists also detected methane and carbon dioxide, classic greenhouse gases often linked with biological and geological activity. There are even tentative signs of dimethyl disulfide, DMDS, another complex molecule potentially tied to biology. But DMS? That's the showstopper, because here on Earth, it's a biosignature, a chemical shout from microbes that life is thriving. The method behind the magic, how JWST caught the signal. Let's break it down. JWST appeared at K2-18b during a planetary transit, when the exoplanet passed in front of its star. During that moment, a fraction of starlight filtered through the planet's atmosphere, and that light carried secrets. JWST's instruments, especially its near-infrared spectrographs, split the light into its constituent wavelengths. Like decoding a barcode, scientists could then read the chemical fingerprints of the atmosphere. What they saw? Molecules absorbing specific wavelengths in exactly the way DMS and other potential biosignatures would. These weren't random flukes. The readings matched lab-tested signatures, powerfully and consistently. It's hard not to feel a rush of hope. This isn't just about astronomy, it's about us, about identity, legacy, our place in the universe. For centuries, philosophers, scientists, and poets have dreamed of proof that Earth isn't an exception, that life isn't a cosmic accident. And now, a hydrogen-rich Haitian world with a possible ocean and biosignature gases is whispering. Maybe. And yet, there's caution too, because extraordinary claims demand extraordinary evidence. The scientific caution. Why we can't celebrate just yet. Let's pump the brakes, just a little. Even though DMS is exciting, this is not confirmation of life. Not yet. Scientists are the first to admit it. These signals are tentative, based on subtle atmospheric measurements that require meticulous analysis and replication. Why the hesitation? Because non-biological processes, such as volcanism, stellar radiation effects, or complex photochemistry, could possibly mimic the same signals. The Earth's atmosphere is rich in biological DMS, yes, but that doesn't mean every DMS molecule in the cosmos comes from a microbe. As astrophysicist Niku Madhusudan, who led the study, puts it, this represents the most compelling evidence thus far that life could exist elsewhere. I can realistically predict that we will confirm this signal within 1 to 2 years. So we're close, closer than ever, but not quite across the finish line. The skeptic's corner. Not everyone's convinced. Within the scientific community, not everyone is on board. And that's a good thing. Peer review thrives on skepticism. Critics argue that statistical confidence is too low to draw firm conclusions. Some suggest the data could be instrumental noise or atmospheric modeling artifacts. Others warn that confirmation bias, our yearning for alien life, could be influencing how data is interpreted. NASA's official position? Cautious optimism. No press conference, no headlines shouting alien life found. Just a patient, methodical march toward truth. Because science isn't about hype, it's about repeatability. The planet in question. What makes K2-18 so special? Let's zoom in on the star of this cosmic mystery. K2-18b is a Hycean planet, a theoretical type of world with a hydrogen-rich atmosphere and a deep ocean beneath. It orbits in the habitable zone of a red dwarf star, close enough to potentially allow liquid water, but far enough to avoid boiling. At 2.6 times Earth's radius and about 8.6 times its mass, K2-18b is not Earth-like in size, but its structure might support a temperate, water-covered environment beneath a thick atmosphere. Imagine an alien ocean, shielded from radiation, teeming with microbial life. If life evolved there, it wouldn't need land. It wouldn't need sunlight, just chemical gradients, warmth, and time. What happens next? The road to confirmation. So what's the plan now? JWST's next steps are already in motion. Follow-up observations using its mid-infrared instrument, MIRI, will provide deeper insight into DMS, DMDS, and other molecular signatures. Independent teams around the world are cross-analyzing the data, looking for instrumental consistency and model validation. Over the next 1 to 2 years, scientists hope to verify the signal's repeatability, test alternative abiotic hypotheses, conduct comparative analysis with other exoplanets, refine models of Hycean world atmospheres. Only then, if all non-biological explanations are ruled out, will we have the confidence to say, this might be life. Are we alone? James Webb's discovery on K2-18b. It's a question older than civilization itself. Are we alone in the universe? From ancient myths to modern science fiction, humanity has stared at the stars, searching for a sign, any sign, that we're not the only intelligent beings in this vast cosmic ocean. Now, in 2025, thanks to NASA's James Webb Space Telescope, JWST, that question has never felt more immediate. K2-18b- a blue speck orbiting a distant star in the Leo constellation has become the most likely candidate for extraterrestrial life. Not little green men, not sprawling cities, but something even more profound: biochemical evidence that life may be possible elsewhere. Let's dive into what JWST found, why it matters, and why the question, "Are we alone?" just got harder to ignore. A discovery unlike any other: the potential biosignatures. In one of the most thrilling announcements of this decade, the James Webb team revealed the presence of dimethyl sulfide DMS and dimethyl disulfide DMDS in the atmosphere of K2-18b. Here's why this matters. On Earth, DMS is a gas produced almost exclusively by living organisms, primarily marine phytoplankton and certain bacteria. It doesn't come from volcanoes. It doesn't arise from rocks. It's a biosignature, a possible chemical fingerprint of life. Even more startling, the concentrations detected were thousands of times higher than what we see on Earth. If you've ever dreamed that science would one day find a signal from another world, this may be it. Not in the form of radio waves, but in the quiet whispers of molecules drifting through the skies of an exoplanet hundreds of trillions of kilometers away. A planet that could host life as we don't yet understand it. K2-18b is no Earth twin. It's classified as a Hycean world, a planet with a hydrogen-rich atmosphere and possibly a global ocean. These types of planets are larger than Earth, often 2 to 3 times its size, and wrapped in thick, steamy clouds that may cloak entire alien oceans. The presence of DMS and DMDS was not all JWST found. The telescope also detected methane and carbon dioxide, gases that, while not definitive proof of life, often accompany biological activity. Together, these molecules paint a picture of a chemical environment that is surprisingly Earth-like in its complexity, and perhaps even more biologically active. If you see yourself as someone who believes in the power of data, discovery, and daring to ask big questions, this moment is tailor-made for you. Final thoughts. Maybe this isn't the answer, but it's the right question. K2-18b may not yet prove that life exists beyond Earth, but it reaffirms why we look up, why we build billion-dollar telescopes, and why we dream. The question, are we alone, isn't just scientific. It's spiritual, emotional, human. We don't have the final answer yet, but for the first time, we're close. So what should you do? You've just heard the story of one of the most profound scientific mystery of our time. Now ask yourself, will you be someone who waits for answers or helps share the question? Will you follow the data, the doubt, the daring search for truth? Will you see the universe as silent or as full of possibility?